from SCCF, Mark Thompson. Thank you.
Hi, I'm Mark Thompson with Sanibel Captiva Conservation Foundation Marine Lab. I'm going to talk for a short period of time on some initial monitoring results for a filter marsh, water quality filter marsh that the city of Sanibel constructed. SCCF has been monitoring the marsh for the last year. Next. Most of you know where Sanibel is, and the location of the filter marsh is on Cassiabel, just off of Periwinkle, kind of in the central eastern part of Sanibel. Next. This should have multiple, well, the red line here is the Sanibel Slough, which locals call it the Sanibel River. The slough was designated as an impaired water body by Florida DEP due to elevated levels of nitrogen and phosphorus, and a TMDL was implemented for the Sanibel Slough, and it's separated into two basins, East and West Basin, but basically the filter marsh is located adjacent to that Sanibel Slough on the East Basin of the Sanibel Slough. The white circle is where the filter marsh is. Basically, the way it operates is we pump out of the Sanibel Slough, pump it westward through the marsh, and discharge southward back into the slough. So you kind of have this continuous loop going from the Sanibel Slough through the filter marsh and back in. Next. We monitored the influent and effluent using automated samplers. We used 24-hour composites to characterize both the influent and effluent and get an idea how well the filter marsh was reducing nutrients. Next. Okay, we sampled the influent and effluent over the past year 9 times. And we did an additional 3 events where we sampled internally in the filter marsh to get an idea of where the nutrients were being removed within the filter marsh, if the different stages in the filter marsh did different jobs out there. So we did 3 internal sampling events along with the 9 events where we sampled just influent and effluent. Next. You can, next. All right. Okay, on the effluent, basically we monitor the flow rate using a V-notch weir and a pressure transducer with the Campbell data logger that logs elevation, and we convert that into flow rate. For the influent, they use a strap-on ultrasonic flow sensor on the influent pipe, which had a little bit of problem with keeping it well lubricated to keep a constant contact with the pipe itself and recording flow. But the flow is recorded hourly, and we can look at that data real time. Next. What we found monitoring the influent and effluent, we monitored, like I said, 9 different times just the influent and effluent from the filter marsh. And due to pumping issues and getting to know how to operate the filter marsh, we had a wide range of flow rates that the marsh was flowing at the times we sampled. So that worked out in that we could plot the TP and TN removal through the marsh based upon these different flow rates we monitored at. And we found that there seemed to be, a pretty optimal flow rate range where we got the best removal under these conditions. Next. We came up with some empirical equations to predict TN and TP based upon flow. Next. And fitted those curves, and then we looked at where we had the optimal flow rate going through the system for TNTP removal. So basically, it looked like somewhere between 300 and 400,000 gallons per day, which is a loading rate of really low loading rate of like 0.1 cubic meter per meter square for that filter marsh, which is about 3 acres. Next. This is what the filter marsh looks like. The first stage where you pump the Sanibel Slough water into is heavily vegetated. It grew up nice and quickly, lots of cattails. It's even more dense than it looks in this first stage picture. Second stage is about a third of the way through the filter marsh. It's pretty heavy in cattails and rushes and a lot of vegetation. And then once the water comes out of the second stage, we go into the third stage, which basically right now seems to be more like a shallow lake. The vegetation didn't really get a chance to take in that portion of the filter marsh, and we have some chara growing on the bottom of that water body, but basically it looks like more like a lake than a marsh. And from that third stage, it discharges back into the Sanibel Slough. Next. So what we found when we did the internal sampling is for total nitrogen, we got overall about 19% removal rate of the nitrogen coming in. And you see that most of the removal took place in the first stage, a little bit in the second stage, and not much at all happening in the third stage. Next. Pretty much the same thing for TP. You got quite a bit more removal than you did with the nitrogen, but the first stage took care of a lot of the phosphorus. You got a pretty significant removal in the second stage, and then in the third stage, not much going on at all. Next. All right. So looking at nitrogen, like we said, in the first stage, got about 18 to 19% removal, an additional 4 to 5% removal in the second stage. And then going through the third stage, we actually had some nitrogen released on the average back into the water column before it was discharged into the Sanibel Slough. And that should be 18.9% N removed, not P removed, sorry. Next. Okay, here's phosphorus. Better percent removals here. 52% of the phosphorus coming in was removed in that first stage, another 16% in the second stage, and a tiny bit removed in that lake-like third stage before we discharged into the Sanibel Slough with a cumulative percent removal of near 70%. Next. Also, the Sanibel Slough is high in chlorophyll A. The TMDL, the goals of the TMDL is to try to get the chlorophyll levels down to around 21 micrograms per liter. Right now, it ranges anywhere between 30 to 60 micrograms per liter out there. But what we found in our sampling events over the course of the last year was that the filter marsh really knocks down the chlorophyll. Basically the phytoplankton that's living in this Sanibel Slough don't know what to do in the marsh, and you're removing a lot of that chlorophyll, and the marsh doesn't seem to be putting much more or any back into the water column as is discharged out. So we get a 74% removal of chlorophyll in the water flow through the marsh and going back into the Sanibel Slough. Next. And the marsh is a bit shallower and wider than the Sanibel Slough. Get a lot more sunshine, heat, and we found overall that we get a temperature increase of maybe 5 to 6 degrees C as we go through the treatment train. So the marsh is warming up the water some before it puts it back into the Sanibel Slough. Next. Turbidity. Overall, we get a reduction in turbidity by about 50%. So it's doing a job on turbidity. The Sanibel Slough itself is usually not that high in turbidity. Most of the turbidity comes from chlorophyll A. So we've already seen that going through the filter marsh removes a bunch of the chlorophyll A, and that probably attributes to the turbidity reduction. Next. So the TMDL for the Sanibel Slough, the goals for the TMDL were a 74% reduction in phosphorus coming into the slough and a 54% reduction for nitrogen coming into the slough. Those are pretty big reductions. So we had pretty big goals. And this project, the Jordan Water Quality Filter Marsh Project, we had hoped that we would get some significant reductions in the amount of nitrogen and phosphorus for the Sanibel Slough so that we could apply those towards the TMDL goal. So what we found was for TN, the estimated actual TM removed per year from the slough was about 40% of the TMDL goal, which was still quite a bit less than what the engineering target for the marsh was. While phosphorus, we had about 45% of the TMDL goal met, and we exceeded the engineering target for that. So phosphorus seems to be doing a bit better than the nitrogen removal at this point. But both of them are getting us closer to the TMDL go for just this one project on Sanibel. Next. The original design suggested a best nutrient removal flow rate, which was about 4 times what the first year average flow rate was through the marsh. We had lots of, like I said, we had problems, issues with the pumps, getting them to turn off, turn on at the right water levels. We think we're getting to the point where we're getting those issues ironed out, and by improving the flow rate, by improving the amount of water we pump, increasing that over the course of the next year, we're thinking that the mass removal over the course of next year could be increased with a better removal, load removals over the course of next year. Next. Another thought is the third stage, it's deeper. Fewer plants took hold before we flooded the marsh, before the marsh was flooded. Right now, there's not really funds or anything to add more plants, but we're hoping that eventually the marsh will fill in with natural recruitment, and with more plants in that part of the marsh, we'll get some greater nutrient removal going on in that third stage. Next. And I guess that's it for this presentation. It was just a short overview of what we found in the first year for the marsh.
Well, great. Thank you very much. And now is the time for everyone to enter your questions at menti.com using code 639808. So please, again, do not use the chat or the raised hands. We're going to be taking these questions as they're entered, and I'll turn that back over to you as the presenter to answer these. Okay, is the TN depositing in the sediment? If so, is it susceptible to be remobilized with a storm surge? I imagine that some of the TN is being deposited in the sediment. I think there's probably a lot of denitrification going on, and some of it's in the plants. But we are out on the island, and we are susceptible to storm surge. So yes, I mean, it is possible that we could get a remobilization of nutrients from the sediments from a big storm surge, though it's more or less in the interior of the island, so it might take a pretty good storm, which is very possible to actually affect it, other than increased freshwater flow rates from the Sanibel River. Did the engineering plan take into account the optimal flow rate your data identified? That is, did the plan accurately predict what would be optimal? So far, we are not seeing that. It seemed that the engineering model predicted that the optimal flow rate would be, 3 or 4 times what our optimal flow rate predicted by our curve suggested so far. But we still need to collect a lot more data. We need to see that once we get the issues with the pumps and all figured out, what a continuous higher flow rate does through the marsh, and see if it does end up lining up more with the engineering estimates. But right now, it looks like the optimal flow rate might be quite a bit less than the engineering design's prediction. What are the sources of nutrients? For Sanibel, I mean, golf courses are our single major source out here. We don't really have much industry, and we have lots of great ordinances trying to minimize stormwater runoff and nutrients in stormwater runoff. We have one of the first fertilizer ordinances. We have stormwater design ordinances and vegetation ordinances. So one of the things that we do have phosphorus-wise is we use reclaimed water on the golf courses and many of the I guess commercial facilities along the Gulf for irrigation. So the wastewater from the wastewater treatment plant, after it's treated, it's a secondary treatment plant, is applied to the
applied for irrigation at many places throughout the island. And we've correlated increased phosphorus concentrations in groundwater, surface water runoff, lakes, in these areas where we use that reclaimed water. So the city has undertaken a project to upgrade the wastewater treatment plant to remove additional nitrogen and phosphorus. And that should be coming online in the next 2 years or so. Let's see, what is the approximate detention times through each of the 3 stages during the sampling for the data presented on nitrogen phosphorus? That's, you know, I need to calculate that, sorry. I don't have that right off hand right now, but the retention times that we're seeing are, you know, a lot longer than what the engineering plan was. But the other thing is we're operating the marsh right now at a shallower depth than the engineering plan originally suggested. Let's see, any consideration of replanting the 3rd stage? Yes, there is consideration. That is somewhere on a list of hopeful things to do that the city would like to do at some point, but you know, it depends upon finding the funding and all. Are nutrient species changing from inorganic to less biologically available forms? No. I mean, basically, it seems like what we have going in there is pretty much organic forms of both P and N going into the marsh. We're almost at detection levels for both of the in that area going into the marsh. So there's not much as far as species change goes. Coming out of the marsh, we got about the same really low inorganic nitrogen and phosphorus levels as we have coming in. And you know, the Sanibel Slough itself has a really long residence time, and lots of things are being converted into organic forms in the slough itself. Is the 3rd stage intended to be lake-like or eventually more marsh-like? It wasn't intended to be lake-like. It was intended to be another, you know, vegetated marsh portion with 2 lakes in the middle of that stage. But I guess the plants just didn't take before it was flooded and didn't have good recruitment yet. See, short-circuiting was observed in the stormwater treatment areas in the Everglades. Reducing short-circuiting improved treatment efficiency. Any evidence of short-circuiting in your system? No, we haven't. There's not that great a chance of short-circuiting in that design, and we do see where there are places in the marsh where elevations in one section are a lot lower on one side of the marsh than the other, so we're not utilizing, you know, the entire marsh when we run that really low flow rate, but probably not. Any comparison of your data with the STA areas, e.g. STA 5.6, plant selection, removal of nutrients? Not yet, but that's something that I'm working on right now. We're working up the data and writing up the report for the first year at this point. So that's something I'm looking at getting the comparison point right there. Does your study support keeping littoral zones with aquatic plants in stormwater ponds in the ERP permitting process? Yes, I would say. You know, it's just the idea that looking at within our filter marsh itself in the area where we don't have much vegetation in our littoral zones and all, you know, we don't have much going on there, but where we have lots of vegetation, we get a lot of good nutrient removal going on. So yes, I would say this supports that. Besides the filter marsh, what other methods are being used to bring the waters back to an unimpaired status? One of the other biggest projects that are going on right now, I mentioned, was the treatment for the wastewater treatment plant. You know, upgrading from secondary treatment, getting rid of a lot more of the phosphorus and nitrogen, which then is applied as irrigation water to the golf courses and resorts around here, which ends up back in the Sanibel Slough. So we estimated that by doing, that's probably going to be the largest single project that improves water quality in the Sanibel Slough over time. So we'll see what goes on in the next year or two with that. And in addition to this, plus we've got a lot of homeowner association based projects that the city has implemented, where they can interact online to see what the water quality is in their lakes or their canals behind their homes, and what they can do specifically at their home site to improve that, you know, vegetation or you know, installing floating islands or whatever if they live on a lake. But we have this interactive website on sanibelcleanwater.com that you can look at, and each of our residents can go in there and compare their water quality for their water body nearest to them to any of the other areas on Sanibel, and compare to state water quality standards. So that gives them some incentive to try to improve water quality in their area by modifying their landscape. Let's see. Do the low NMP removal rates for the lake-like portion of the filter marsh suggest that we're foolish to maintain most of the thousands of neighborhood detention ponds in Southwest Florida and lake-like states rather than marsh-like states? You know, I would say yes, and that's one of the things that that the City of Sanibel's interactive websites tries to get across to homeowners associations, how they can improve their water quality through using vegetation and all, and not mowing and fertilizing right down to the water's edge, and using herbicides to kill the vegetation along the water's edge and all. So yes, I would say that our findings, you know, all support the idea that we need to have a more natural shoreline than what you normally see in stormwater ponds around here. Did you calculate the carrying capacity equilibrium level of NMP for the marsh? Will management include biomass removal to increase in absorption? Let's see, I can't see the rest of the question. But we are doing that right now. and we do plan on periodically harvesting, especially the cattails from the marsh to remove some NNP and to improve P retention.